Hello. Not too many people. The weather is, I don't know what to say. Is it good or horrendous? Feels like I'm melting at times. Yeah, so sorry about last week. Last Tuesday I had a baby, so I couldn't do the webinar. So now yeah, so I'm a proud, happy dad. Okay, so today I want, thank you, Amanda. Today I wanted to go through some inequalities. And this is one thing that is barely touched in UK schools for some reason. And I'm going to show you a method called the method of intervals. And I really want you to appreciate how easy and flexible it is. Okay, I'll share my screen. Share my screen. Okay, here it is. Now let's have a look. Method of intervals. Problem 1. So you need to find the x's for which x times x minus 3 is greater than 0. And can anyone solve it in their head? Or just help me how to approach this? X is less than 0 or x is greater than 3. That is true. That is true. How did you do that? Can you elaborate? You can use your mic. Okay. Oh, skips the graph. That's a brilliant method. Yes, absolutely. But like, even if you don't know how the graph looks like, you know that something happens when x is 0 and something happens when x is 3. Okay, so from here, something happens when x is 0 and the same when x is 3. In this case, they are zeros, and indeed, these are zeros. And if you draw them, you put 0 and 3, and we know that it's a parabola that crosses like this, and we know that it is positive here, and it's positive here. Okay. This can be written as x belongs to from minus infinity to 0, or from 3 to plus union from 3 to plus infinity. This is the solution. This is equivalent to saying x less than 0, x greater than 3. You could alternatively do this. You can say, well, this is multiplication of two numbers, right? So we know that if a times b is greater than 0, that means that a is greater than 0, b is greater than 0, or a is less than 0, b is less than 0. And in this case, you would have if x times x minus 3 is greater than 0, that means x is greater than 0 and x minus 3 is greater than 0, or x is less than 0 and x minus 3 is less than 0. This case is here you have x is greater than 0, x is greater than 3, x is less than 0, x is less than 3. So overall, this is x greater than 0. Oh, sorry, x is greater than 3, or x is less than 0. This method is way longer. It probably makes sense. It's quite easy. But it's much longer, especially if it's going to be harder than that. So the method of intervals. So here comes the method of intervals. Write the inequality as f of x less than 0 or f of x greater than 0. Basically, make the right-hand side 0. And we have x times x minus 3. The right-hand side is 0. Identify where the function does not exist. Well, this exists everywhere. Identify the critical points, 0 or discontinuities. We've identified zeros is 0 and 3. The function will have constant sign on each interval between critical points. So what does that mean? So we have x. We've identified the critical points. So 0 is a critical point, and 3 is a critical point. Now, the function will have constant sign. So in between the critical points, this function will not change its sign. So you would have, let's say we are greater than 3. So we check x equals 4. We choose any point from the interval. Yeah? Check x equals 4, and it's going to be greater than 0. 4 times 1 is going to be 4 times 4 minus 3. That's going to be greater than 0. So that means it is plus. On this interval, it is positive. That means positive when x is greater than 3. Then you check any number between 0 and 3. Check x equals 1. And it's going to be 1 times 1 minus 3. That's going to be negative. So it's negative when x greater than 0, less than 3. So it's negative here. And it's going to be positive here by taking any negative number. You don't need to check that. You know that the sign changes at the critical points. So usually the sign changes at critical points. You start from here. So you go positive, negative, positive, and then you choose the ones that you need. So you choose the positive ones. And the answer is x belongs to minus infinity to 0, or from 3 to plus infinity. Is that making sense? Like, how much sense does it make on a scale of 1 to 10? Let me know, please. Okay. So let's look at this one. So this is slightly different. So the difference here is that we have less than or equal to. That's important. and we have a square here. That means x equals 2 is a critical point, but there's no change of sign. So x equals 2 is a critical point. But no change of sign. So x equals 5 is a critical point. Critical, and change of sign. Okay, so we draw a line. We put the critical points. So x equals 2. Now this time we draw solid points because x can be equal. They can be equal to 0. And I mean filled in. So that's 2 and that's 5. And now we choose the sign. It's very easy to start from the right. You say we check the sign on plus infinity. So we choose a really big, so for this choose a big value for x. Let's say 1,000. And it's going to be positive. It's going to be positive. It's going to be negative. And we say there's no change of sign on x equals 2. So it's going to be negative. And then we draw the line. Now we draw it like this with a square because it's a solid point. It's a filled in. This one. And then this one, like this one, and this one. So positive, negative, negative. And in this case, because we need the negative values, it's a bit sad, but anyways, we need the negative value. So it's all of this. So we can say that x belongs to the interval from minus infinity to 2, or from 2 to 5, square bracket. But because 2 is included, we can just say x belongs to minus infinity to 5, and that's it. Now, if this was less than or equal to 0, this was less than 0, this would be slightly different. So you have the critical points 2, 5, and you have positive, negative, negative. So you go, it's a round bracket now. Now you would have x belongs to minus infinity to 2, and from 2 to 5. And if it was greater or equal to 0, greater or equal to 0, this would be like this. All right, so 2, 5, so they are filled in points, positive, negative, negative, so square, bam, bam, bam. Wow. So we are interested in the positive ones or 0. So it's positive when x is greater than 5, but it's 0 when x equals to 2. So x belongs to 2, the number 2, or anything more than 5, anything from 5 and above. Because indeed, for this thing to be positive, it needs to be equal to greater than 5, or it could be 2. Do all of these make sense to you on a scale of 1 to 10, please? Again. Good. So, without any further ado, let's jump into something really scary looking, but actually something super easy. Look at that. You have a huge fraction, and any traditional method of solving inequalities would make you exhausted even before you start. If you try any traditional methods. Oh, I mean, drawing a graph is a very good one. But then how do you draw a graph like this if you don't have a calculator? So as I said before, so you draw a line. You identify the critical points. If it's a 0, because it can be equal to 0. So if it's a 0, you make it a solid point. If it's a discontinuity, so the function doesn't exist. So let's see. So where does the function not exist? The function doesn't exist when x equals 5. So we put that 5. And we say a round point, because x cannot be equal to 5, because otherwise it's division by 0. X cannot be equal to 9. 9, so that's a discontinuity. X cannot be minus 2. Now, are there any discontinuities here? Like, what about this? Well, as a matter of fact, x squared plus 4x plus 6. What do we know about this? Can it be equal to 0? Can this thing be equal to 0? No, because the discriminant is negative. In other words, is greater than 0 for any value of x. For any real value of x, this is positive. You can also prove that quite easily. You can complete the square, x squared plus 4x plus 4 plus 2. And this is a completed square. So that's going to be x plus 2 squared plus 2. Now this thing is non-negative. X plus 2 squared is always positive or 0. And plus 2, it will always be greater than 0. Always. So this can actually ignore it. It's just like a positive, it's a positive value. It can never make the fraction negative. Right. Now let's look at the zeros. When x equals 0, that's a 0. So this is a solid point. So filled in because x can be equal to 0. When x is 4, it's a 0. And when x is minus 3, minus 3. But keep in mind that the sign does not change at minus 3. So no change. No change. So we choose a big value of x, let's say 100. We put in 100. If we put 100 instead of x, you don't need to do any calculations, but is the fraction going to be positive or negative? If x is 100, will the fraction be positive or negative? So imagine substituting x equals 100 into, it's going to be positive. Yeah, you don't need to do any calculations to see that it's positive, because each element is positive, right? X is positive, x minus 4 is positive, x plus 3 is positive. They're all positive. Therefore, above 9, it's positive. And now the signs change everywhere except minus 3. So negative, positive, negative, positive, negative, negative. And all you need to do is draw the line. And now if it's a circle, it's a round. So go bam, bam. It's a square now. Bam. And once again, so it's a square, but like this. Wow. So it's going to be positive or 0. So it's positive here, positive here, positive here, and 0 here. So the answer x is 3, or anything between -2 and 0, or anything between 4 and 5, 4 including, 5 not including, or anything above 9, from 9 to plus infinity. Yes, I meant -3. Thank you. That's it. Right. Did you know how to solve this inequality before today? Yes or no? Okay. Right. Yeah. So, do you understand how to do it now? Oh. And this method can be extended. So, like, as you can see, so the function just changes sign. So if you draw this is like a sketch of the graph, sort of, because if you sketch the graph, it will look something like that. Of course, not literally, but it will be positive here, negative here, positive here, negative here, positive here, positive, negative. The signs change unless there's something interesting going on. So let's do some more examples. So this one. So here we have 1 on the right-hand side, so we need to take it to the left. So we have x over 2x squared plus 5x plus 2 minus 2x squared plus 5x plus 2 over 2x squared plus 5x plus 2. Yeah, so this is 1, obviously. So this is, we're subtracting 1, so less than or equal to 0. And can we factorize the bottom part? Cheat a bit. it's the heat. Can't solve quadratics when it's above 25 degrees. 5, 2. So it's 2x plus 1 and x plus 2. So I factorized the denominator, and here we have minus 2x squared, x minus 4, 4x minus 2 less than or equal to 0. So we take minus 2 out, minus 2, open bracket, and this becomes x squared plus 2x plus 1, 2x plus 1, x plus 2, 0, and minus 2, x plus 1 squared, 2x plus 1, x plus 2. So the first step is usually the hardest, because everything else is just drawing. So x. So critical points. 1. Oh, sorry, that's minus 1. Minus 2, and it's a round point, minus 2, because it's in the denominator, and minus a half, which is also in the denominator. And there's no change of sign at 1, so there's no change of sign here. We choose a really big value for x, and we check the sign on plus infinity. So if x is 100, what is it positive or negative? Negative, indeed. So negative, positive, no change, positive, then change of sign, negative. So we go bam, 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 down, down. Less than 0, so it's going to be this point, and this. So x belongs to minus infinity to negative 2, union minus 1, and from minus a half to plus infinity. That's it. So the hardest, so the hardest bit is just to put it into this form, and everything else just becomes very basic. Sometimes you need to sometimes you need to find some sort of trick to help you, because, well, look at that. If you were to find the common denominator, it would be x, common denominator would be x minus 5, x minus 4. And that would mean that this has to be multiplied by x minus 4. So what that means is you would have a polynomial of the 5th power. Now, whenever you see a polynomial, whenever you see the potential of a polynomial of the 5th power, your task is try to avoid it, because, oh, well, I mean, you probably can solve an equation of the fifth order, an equation of 5. You can probably solve a polynomial of power 5, but it's something I don't like doing, and something that you need to understand, that physicists and mathematicians are quite lazy. If you can avoid it, then do. And the magic thing is here, because you can see that this bit is in fact has a common, it has a common factor with this bit. So what we're going to do is we're going to split this into 2 fractions. So it's going to be x to the power 4 minus 5x cubed over x squared minus 5x plus 3x minus 25 over x squared minus 5x greater or equal x squared minus 1 over x minus 4 plus 5 over x. And look at that. This simplifies to x squared, because if you take x squared out, yeah, do I need to explain why this is x squared? If yes, please let me know. There's going to be x squared plus 3x minus 25. I'm going to factorize this. It's going to be x minus 5 greater or equal x squared minus 1 over x minus 4 plus 5 over x. And as you can see, x squared cancels. And we're left with a much easier x minus 25 over. Now the common denominator is still x times x minus 4 times x minus 5. So we multiply this by x minus 4, x minus 5 plus 1 over x minus 4. So we multiply this by x minus 5 minus 5 on x. And this is x minus 4, x minus 5. And that's greater or equal 0. Okay, and then we just multiply. So x times 3x, so that's 3x squared minus 25x minus 12x plus 100 plus x squared minus 5x minus 5x squared minus 9x plus 20 x minus 4 x minus 5 greater or equal 0. So 100 and minus 100 cancels. 3x squared, so 4x squared minus 5x squared. So that's minus x squared. 1, 2, 3. And minus 25x minus 12, that's minus 37. Minus 5, that's minus 42. And plus 45, there's a plus 3x. Plus 3x. Right. So that's x So all as well. We can factorize this. And I would say, so this is x multiplied by 3 minus x minus 4, x minus 5 is greater than 0. Can we simplify by x? What do you think? Can we simplify it by x? Anyone? Any ideas? Can we just cross out the x's? I mean, you can guess from my tone of voice that probably not. But why? Yeah, so x is actually a discontinuity. Yes. If x is 0, the function doesn't exist. So you have to put it here. You have to put it here, but because it's x and there are two x's, we say it's a root of multiplicity 2. In other words, the sign doesn't change at x. So we need to put it. So it's going to be, so the points are 5, 5, 4, 3. Now 3 is a solid one. 3. And 0. And 0 is a discontinuity. And so there's no change here. No change. It's sort of equivalent that it was x squared, because in a fraction, it doesn't matter where it's in the top and the bottom. If it's 0, if it changes sign, the whole fraction changes sign. If it doesn't change sign, the whole fraction doesn't change sign. So if x is really big, so if x is 1,000, is the fraction positive or negative? If x is 1,000, is the fraction positive or negative? Negative, true. So it's negative, positive, negative, positive, positive, because there's no change at 0. And then you just draw. And you need the positive values. The answer x belongs to minus infinity to 0, from 0 to 3, and then from 4 to 5. Full stop. So the beautiful thing about the method of intervals, it just always works. So let's have a look at some special cases. Modulus. Now, if you were to do it properly, you could say that modulus of x minus 6, by definition, is equal to x minus 6 if x is greater or equal 6, or it's equal to minus x plus 6 if x is less than 6. And then you could do it that way. Actually, it could be much easier. Like this thing is always always greater than 0. It's positive. It's a modulus. Well, greater or equal to 0. So we need to ask ourselves, is x equals 6 a solution or not? X equals 6 a solution or not? If we substitute x equals 6, does it work? Yes or no? No. So if x equals 6, the inequality is not true. So x equals 6, not a solution. A solution. Yeah, so we're not going to do this. This is way too complicated. That means that if we ignore x equals 6, we can just always say, well, yeah, this is, because this is always positive, the whole thing is negative when x minus 8 is negative, and it's positive when x minus 8 is positive. So the f of x, the expression on the left, that's f of x, is negative when x minus 8 is negative, and f of x greater than 0 when x is minus 8 is less than 0. It's the other way around. Okay. Right. It's positive when it's positive and negative. Of course, x is not equal to 6. X is not equal to 6. Therefore, it's negative. So we only need the negative part. So the answer is so it has to be less than 8. You could say that this is equivalent to having 2 critical points. Two critical points at 6 and 8. And no change of sign on 6, because it's always positive. So it's positive, negative, negative. So we are interested in the negative part. So x belongs to minus infinity to 6, and from 6 to 8. To 8. Or you could also say, or you could just say x is less than 8, but x is not equal to 6. This one. Well, let's have a look. So first of all, x minus 2 has to be positive, because you can't take square root of a negative number. Therefore, x minus 2 has to be greater or equal to 0. Okay, so we draw the line. 2. So it cannot be less than 0. So this one just doesn't exist. Anything less than that, less than 2, you can't be a solution. So x greater or equal to 0. Now x minus 5. Now once again, you have two critical points, 2 and 5. 2 and 5. And 2, well, there's no change of sign because you can't have anything to the left of 2. And so choose a very big value for x, so plus, minus, and stop. And stop here because everything to the left is meaningless. So you go bam, 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 bam. And you need positive or 0. That means positive or 0. So our x, the answer is x belongs to 2 or 5 to plus infinity. Or you could just use common sense to say, well, look, the square root is always positive. So in order for the expression to be positive, x minus 5 must be positive. But you also need to test the critical points. So you don't necessarily need the method of intervals here. You could just look at it and say, well, it's positive when x minus 5 is positive, because square root cannot be negative. Square root is always positive. Therefore, x is greater than 5, but also x is equal to 2. It's sort of like testing every single value. The thing about the method of interval, because if the function is continuous between the critical points, that means it has the same sign everywhere. So you only need to test one point. So it's sort of, you can test every single value for x and see whether it works. Okay? Because we're using the fact that it is continuous between the critical points. So at critical points, it doesn't have to be continuous. So we test the critical points separately, and we test each interval between the critical points. So this is an example where traditional methods fail. Because typically, what you are taught in school, for example, that you need to square both sides. When you have a square root, you square both sides. And then solve it. And that is only true when both sides are positive. Now, the left-hand side is always positive. Positive. Or 0, of course. Or 0. So you can always safely square it because it's positive. But the right-hand side is not necessarily positive, right? Because if you see 2 is certainly greater than minus 3. But if you square both sides, it's you have 4 greater than 9, which is not true. True, not true. So you can only square both sides if they're both positive. Otherwise, you get nonsense. So this is why you can't always square. Now let's have a look. So basically what I'm saying is, so only makes sense, or the domain of the domain of the expression, or the domain of the inequality, we only have 3x plus 4 has to be greater or equal to 0. Otherwise, the square root doesn't exist, and the expression is meaningless. In other words, x has to be greater or equal minus 4/3. So if 2x minus 4 is negative, the inequality is true. Three x plus 4 is greater than 2x minus 4, because this is a positive, and it will always be bigger than a negative. Positive is always bigger than a negative. Therefore, if x is less than 2, combined with the limitation, therefore x belongs to minus 4/3 to 2 is a solution. What about x equals to 2? If x equals to 2, then we just test. So it's going to be positive, and this is 0. So that's going to be 6 plus 4 square root of 10 greater than 0, true. So x equals 2 is a solution. If x is greater than 2, then we can square. We can square. Let's have a look. So from here, we have 3x plus 4 is greater than 4x squared minus 16x plus 16. Yeah, that makes sense. We have 4x squared minus 19x plus 12 less than 0. Four and 3/4 x minus 4, 4x minus 3 less than 0. And we can use the method of intervals here. So the critical points are 4 and 3/4. So 4 and 3/4. And it's going to be positive, negative, positive. Right, so we need negative, so anything between minus 3/4 and 4. Right. But we also know that anything between minus 4/3 to 2 is a solution. So 2 is here, and minus 4/3 is here. So this is a solution as well. So the answer, so that means x equals 3/4 to 4 is a solution. So the answer is x belongs to, ooh, is it? Oh yes, it is minus 4/3 to, oh, any questions? Any questions how I got here? We're just combining the three solutions that we've obtained. This solution, and this solution. And if we combine all of them, we get anything between -3/4, including up to 4. Right. How well do you understand on a scale of 0 to 10, please? Really good to see. 10. Brilliant. Okay, so I've run out of questions on inequalities. If you have any questions about the assignment, I'm happy to answer. Otherwise, I have 2 more questions on simple harmonic motion. All right, so a trolley is traveling with speed v, hits a spring. When spring is compressed by L, this trolley becomes momentarily stationary. Find the time it takes to stop the trolley. Okay, so the trolley is traveling at speed v, and the spring is compressed by L. Find the time it takes to stop the trolley. Any ideas? Any ideas? V in terms of t. Well, you can, but how? Well, the topic is simple harmonic motion, and obviously the section from the point where it touches conservation of energy. Actually, not a bad idea. So what you're saying is 1/2 mv squared is equal to 1/2 k L squared. Yes, the initial point is the equilibrium position of simple harmonic motion, of course. So this is the equilibrium position. This is 0. And when it shifts to here, that's the, I mean, you could write this, yes, but you don't know M, you don't know K. That's sort of a problem. So this is not enough. This is not enough to find the. This is not enough to find it. So this is the amplitude. L is the amplitude. A amplitude is L, because it's going to, if it's, let's say, imagine if there was blue tack on the trolley, it would stick. It will then oscillate like this. And the period of oscillation, the time period of oscillation, is going to be 2 pi square root of m over k. Right. But we also know that the maximum velocity in superharmonic motion is omega times the amplitude. So in other words, v is equal to omega times times L. Omega is V over L. And we know that the time period is 2 pi divided by omega, which is equal to 2 pi divided by V multiplied by L. And it will stop. It will take a quarter. It stops in t equals a quarter of a period. It takes a quarter of a period to stop. In other words, it's going to be 2 pi over v L over 4, and that's pi L over 2v. That's the answer. V. Mm-hmm. 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 It takes a quarter of a period to stop, because if you imagine the point where it touches is the equilibrium position. Then it compresses the spring fully, stops, and then goes back to the equilibrium. That's half a period. Then it goes far, if they were stuck, it goes far away to the left, to the farmost position. So if the trolley was stuck to the spring, it would oscillate between points L and minus L. It would oscillate between these 2 points. It goes bam, bam, left, right, left, right, left, right. And it would eventually, sorry, not eventually, whatever I'm saying eventually, No, so it takes a quarter of a period to reach here, then another quarter of a period to go back to the equilibrium, a quarter of a period to go here, and a quarter of a period to go here. So if we look at the graph of simple harmonic motion, we start from equilibrium. So this is the displacement. It takes us over here, here, over here. So it takes a quarter of a period to reach, so t over 4, to reach the maximum, to reach the amplitude. Yeah, does that make sense? It is. Problem 10. A box of mass m has an oscillating attached inside. What is the minimum amplitude of the oscillation so that the box starts to jump on the table? Okay. So we need to look at the forces acting on the box. And when we draw a free body diagram, we mean free body diagram. So we draw just the box. The box, so to understand which forces act on the box, you need to imagine that you are the box. So I close my eyes, I am the box. So what do I experience? Well, I experience the force of gravity. So mg. Then this is capital Mg. This is the gravitational force pulling me down. Now I'm at rest on the table, so there must be a normal reaction force pushing me up. Normal reaction force pushing me up because I'm touching the table. Inside me, there's that sensation of a spring pushing me. Now, if the spring is compressed, it's pushing me up. If the spring is stretched, it's pushing me down. So if it's pulling me down, I probably won't be able to jump as a box. So the spring must be pushing me up at some point. At the moment where I want to jump, the force from the spring, the Hooke's force, must be an upwards force. And what is the condition for me to jump? When you jump, you have this sensation. If you ever jumped into a swimming pool from at least 2 meters, or you went on when you go on a roller coaster, when you're at the top and you start to go down, you have this sensation. What's that sensation called? Astronauts feel it as well. Weightlessness, yes. In one of the previous webinars, I did mention that weightlessness is not the correct term for it. Because do you have no weight when you are falling? Do you have no weight if you are falling? Because astronauts are falling, just like you are falling if you jump into the swimming pool from a diving board. You get this sensation. No, you're not weightless because you're obviously being pulled down by gravity, so you have weight that doesn't change. What do you not have when you jump off a diving board? the normal reaction force. Yes, there's a no normal reaction. So when we say astronauts are weightless, they're not. They're normal reactionless. So a more correct term would be normal reactionlessness, because they're not their bottoms are not pushing against anything. That's the sensation that you feel when you're weightless. When you jump somewhere, you go, or just you jump, just get on the floor and jump. You feel that normal reactionlessness. There's no normal reaction, and that's the sensation that you experience. So in order for the box to jump, so to jump, normal reaction must be 0 or less. Well, it can't be less, otherwise you're stuck to the floor. So no, that means if this is 0, this force must be equal to mg. Therefore, F is equal to mg. In other words, kx is equal to mg. Okay, what is x then? Well, x is the compression of the spring, where x is the compression of the spring. Oh, and capital Mg, of course. Capital Mg. Now, x is a compression of the spring. But when you, well, compression is that the same as the amplitude? Is the compression of the spring the same as the amplitude? Well, let's have a look. When the small mass is stationary, this is the equilibrium position. This is the equilibrium position. But this is the unstretched position. Unstretched position. And this is where we want the mass to be at maximum compression. So this is the compression of the spring X. This we will call X0. This is the extension of the spring when the mass is stationary. And the amplitude is this. The amplitude of the oscillation is this. Amplitude. So in other words, the amplitude is x plus x0. And what is x0? Well, when x0 is when you hang stationary, so it's kx0 is equal to small mg. So x0 is equal to mg divided by k. And we already know that x here is capital Mg divided by k. In other words, the amplitude is equal to mg divided by x plus x0, so mg divided by k. And that is G n plus m over k. That's it. That's the minimum amplitude that you need in order for the box to jump. Okay. Was there anything that we missed from 2 weeks ago? Not really. No. Well, we missed this question, but that's quite a straightforward one. Okay, anything else? X and x0. X0 is the extension of the spring when the mass is not bouncing. X0 is the extension of spring when m is stationary. So it's the difference between the equilibrium position and the unstretched position. Okay, and X is the compression of spring when m is at the top of the bounce, or the top of the oscillation. Okay, let's call it oscillation. Does that make sense? Oscillation. Anything else? Do you have any questions? We have 10 minutes. I can answer a question from, if you have anything from the assignment or not. Last question. The one with the dumbbell. Ooh. Right. Okay, so what you need to consider here is you need to consider the potential energy of the dumbbell. So when if you displace, so let's say the center of the dumbbell is here, and it moves in a circle. So you need to find the radius of the circle first. So because this goes like this and back, so you need to find the radius of that circle. That's the first step. Call it R star, R asterisk. And then if you displace the mass by a small amount, you just displace the center by a small amount, let's say x, you need to calculate the total potential energy of the the change of the potential energy of the dumbbell. Okay, so if you move the mass, one moves down and one moves up, and you need to calculate the total potential energy, and then you just use Vx, the potential energy, is equal to m omega squared x squared. So you find V of x, you find the potential energy as a function of x, then you compare it to this, and this is how you find omega. Does that make sense? You find an expression for the potential energy as a function of x, you compare it to this, and by comparing the two expressions, you find omega. So let's say if this was 3mx squared, that means omega squared would be 3. Right, but it's obviously not. So find omega by comparing. All right. So have a lovely evening, and I'll see you next week. Welcome.